In this lecture, we'll discuss some other important aspects which are falling under the general science, and among those the first one, the universe, and the second one, outer space, then the third one, galaxies, the fourth one, Milky Way, the fifth one regarding the stars, and the sixth one is about our solar system. Then the main center of the solar system, the sun, and what about the Van Allen belt, so first one that we would like to discuss in this lecture is about the universe and what is cosmos. So, when the universe was first conceived of as an earthly unit, it was called cosmos, as opposed to chaos, and the studies relating to cosmos is known as cosmogony or cosmology. So, now we called it as space and space sciences. So, the very history and development of space and space science started with Claudius and Ptolemy, then Copernicus, then Herschel and Hubble. So, a regular inquiry into the universe was first instituted in 140 AD by Claudius Ptolemy, a Greco-Egyptian astronomer. He propounded the theory that the earth was the center of the universe and that the sun and other heavenly bodies revolved around it. There have been several theories since, the more important of which that we would like to discuss here. So, in 1543, the Polish astronomer Copernicus argued that sun and not the earth was the center of the universe. In 1805, telescopic studies made by the British astronomer Herschel make it clear that the universe was not confined to the solar system. The solar system itself was only a part of a much vaster star system called the galaxy. The universe thus became quite expansive, comprising millions of stars scattered about the Milky Way. As 20th century opened, it seems that the Milky Way galaxy, with its cluster of over 100 trillion stars, together with their attendant satellites, and that is the Magellanic Clouds, actually represented all there was to the universe. So in 1925, the American astronomer Edwin P. Hubble pointed out that there were other galaxies in the universe and that the universe actually consists of millions of galaxies like the Milky Way. In 1929, Hubble proved that these galaxies are flying away from each other, and that the farther they are, the faster they fly. This meant that the universe is expanding like a balloon that is being blown up. This movement of star or a galaxy affects its light as seen by an observer. If the star is moving towards the observer, its light will be shifted towards the blue end of the spectrum. If the star or galaxy is moving away from the observer, its light will be shifted to the red end of the spectrum. And this is known as the Doppler effect or shift. The Doppler shifts galaxies so that they are receding and that the universe is a state of rapid expansion. And in that connection, we would like to discuss another important theory relating to the universe, and that is the Big Bang theory. So, a Belgian astronomer and physicist known as Abby George Lemaitre explained this process of expansion as the Big Bang theory. He argued that billions of years ago, cosmic matter or universe was in an extremely compressed state, from which expansion started by a primordial explosion. This explosion broke up the superdense wall and cast its fragments far out into space, where they are still traveling at thousands of kilometers per second. It is from these feeding fragments of matter that our galaxies have been formed. The formation of galaxies and stars has not altered the speed of expansion, and as it happens in all explosions, the farthest pieces are flying the fastest. And another theory that developed relating to the universe is the theory originally known as the continuous creation theory. This theory, originally advanced by two astronomers, Thomas Gould and Harman Bondi, has since received support from the British astronomer Fred Well. So, according to this theory, galaxies recede from one another, but their celestial density remains constant. That is to say, as old galaxies move apart, new galaxies are being formed in the vacancies. These new galaxies are formed from new matter, which is being continuously created to replace old matter that is being dispersed. So, another important theory relating to the universe and that was known as the oscillating theory. And the main advocate among others of this theory was Dr. Alan Sankey. The universe, according to this theory, expands and contracts alternately between periods running into tens of billions of years. Dr. Sandek thinks that some 12 billions years ago, a great explosion occurred in the universe and that the universe has been expanding ever since. It is likely to go on expanding for 29 billion years more, when gravitation will hold further expansion. From then on, all matter will begin to contract or collapse upon itself in a process known as implosion. This will go on for 41 billion years, compressing matter into an extremely superdense state, and then it will explode once again. This is the largest and the very latest theory of evolution of the universe, that the universe is expanding is considered as an established theory. So now we will discuss about another important part of the universe, and that is the outer space. And that outer space consists the light year. So what is a light year? A light year is the distance covered by light in 1 year in vacuum, traveling at a speed of 299,792.5 lakh kilometer per second, or about 282 miles per second. A light year is thus 5.88 million miles. And another part of outer space is the astronomical unit. An astronomical unit represents the mean distance between the Sun and the Earth, calculated on the data supplied by radars. This distance, the astronomical unit, has now become a key constant in determining distance in the solar system. Astronomical unit is terrestrial measurements is approximately 93 million miles or 150 million kilometers. In terms of space dimensions, we may say that a light year is made of about 60,000 astronomical units. And now we'll discuss another most important part of outer space, and that is to be explained. When sunlight, the white light, is passed through a prism, it is broken off into rays of different colors like those of the rainbow. Traditionally, 7 colors are known with which are epitomized by the acronym WAVE, that is violet, indigo, blue, green, yellow, orange, and red. This is called the solar spectrum, with the violet color at one end and the red color at the other end. In studying the heating effects of the solar spectrum, Herschel placed a thermometer in each of the colors of the spectrum and an astrothermometer outside the spectrum at the red end. So, now we will discuss about the infrared. The thermometer outside the spectrum at the red end showed a higher degree of heat than any other inside the spectrum. Then Herschel called these rays infrared, below the red rays. In 1801, the German physicist Johann Ritter discovered that the rays outside the spectrum at the violet end broke down silver chloride more quickly than the rays within the visible spectrum. This came to be called ultraviolet, or beyond the violet rays. It thus turned out that sunlight formed not only a visible spectrum but also an invisible one. Then we will discuss about the importance of angstrom unit. In 1803, Thomas Young, a British physicist, showed that light travelled in the tiny waves of varying wavelengths. The wavelengths were too small to be measured by conventional scales. So, Anders Angstrom, a Swedish physicist, evolved a new scale to measure wavelengths. He chose a unit equal to 10 billionth of a meter. This has since become known as the angstrom unit. 10 angstroms are equal to a millimicrometer, 1,000 of a millionth of a meter, which in terms of modern SI units is equal to a nanometer. So, also we would like to discuss another important part of the outer space, and that is relating to electromagnetic thesis. So, in connection to that, we found the very electromagnetic thesis. So it was developed by James Clerk Maxwell, the British physicist who came out with this his theory. Maxwell argued that electricity and magnetism were different aspects of a single electromagnetic field. Periodical variation in the electromagnetic field produce electromagnetic radiations of varying lengths. The visible light is only one part, and for that matter, a very small part of the electromagnetic spectrum. He also postulated that there can be other invisible relations of much shorter wavelength than the ultraviolet at one end and far longer than the wavelength of the infrared at the other. And now we'll go to another important invention made regarding outer space, and that is the Cartesian waves. So, also the radioactivity. The Maxwellian theory was vindicated when the German physicist Heinrich Hertz in 1857 produced electromagnetic radiations with wavelengths much longer than that of infrared rays. These wavelengths were at first called the Cartesian waves, but eventually came to be known as radio waves. Then in 1895, another German physicist, Nobel laureate Wilhelm Röntgen, discovered what he called X-ray radiation. The X-ray was later found to be much shorter in wavelength than the ultraviolet. The further development was made in 1896 by the French physicist Henri Becquerel, who discovered the phenomenon of radioactivity, for which he received the Nobel Prize in Physics. Becquerel did not at that time known why or in what manner this radioactivity took place. Subsequently, it was found that this radioactivity was caused by the atoms of heavy metal, that is uranium, giving off a constant emission of radiation and particles. It was further shown that this radioactivity was also electromagnetic in nature. Rutherford named it the gamma ray. The gamma ray had a wavelength even shorter than that of the X-ray.